Welcome back. We are in even and odds. This is activity 1.1. Alrighty, let's get started. Joel and Hiram are playing a game using two six-sided number cubes. The number cubes are rolled and the sum of the two numbers shown is calculated. If the sum is even, Joel wins a point. If the sum is odd, Hiram wins a point. So let's annotate to make sure we understand what we're talking about here. They're playing a game and they're using two six-sided number cubes. So what does that look like? Let's remind ourselves. A number cube has numbers 1 all the way to 6. 1, 2, 3, 4, 5, 6, and it looks something like that. And they're using two of them, okay? They are calculating the sum of the two numbers. So the sum, we think of what operation? Addition. Uh-oh. All right. If even is rolled, Joel wins a point. Let's highlight him in blue. So if even, Joel wins a point. Highlighter. And if it's odd, let's just do orange. If it's odd, then Haram wins a point. All right. It says make a list of all possible outcomes when rolling two six-sided number cubes. Now, this list is going to be long. I'm going to tell you that now. But let's simplify this so that you don't have to draw a long list, because we are going to list all of these. But it says make a possible list of them when they are all rolled, or when we do roll a six-sided, two six-sided cubes. Ooh, man, this is tough. All right. So as we know, if we roll one, right, if we roll two ones, that sum is going to then give us 2, but the outcome would be a 1 on one dice and a 1 on the other dice. That would be our lowest, right? And then we can continue our list. Well, I could also roll a 1 and a 2. I could also roll a 1 and a 3, and so forth. I'm not going to write all of those out. But think about, what is the highest amount that could possibly be rolled? Well, I know that we could roll a 6 on one cube. We could also roll a 6 on another cube. Just like we could roll a 6 and a 5. That would be my second highest, and so forth. So we know that all of our possible outcomes would fall in between these two, right? 1 and 1 and a 6 and 6. So now let's create our list to list out our sample space for the possible sums. So our sample space, remember, has braces. And we just noted our smallest amount. So 2 ones I know is going to give me a 2. And then if I roll a 1 and a 2, that can give me a 3. A 1 and 4, that gives me, a 1 and 3, that gives me a 4. Now note, I'm going to be able to roll all of these numbers 2, 3, 4, 5, 6, 7, 8. But remember, our highest here, we annotated, was a 6 and a 6. And a 6 and a 6 gives us a 12. So I know that my numbers can range from 2 all the way to 12. So I'm going to write that 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there's my sample space. That was a really bad bracket. Okay, whatever. All right, let's continue. 3, it says, do you think each of the outcomes in the sample space is equally likely? Explain your reasoning. And number 4 says, predict who has a better chance of winning this game. Explain your reasoning. So what I want you to do now, looking at the data that we've gathered and the information that we know, I want you to answer questions 3 and 4. Take maximum 2 minutes and 2 minutes only to answer 3 and 4. Pause here. Alrighty, let's compare answers. So number 3, I simply put, no, they do not have an equally likely chance, because I can get some numbers with different combinations. So for an example, I could get 7 a couple ways. I can get a 2 and a 5. I could roll a 3 and a 4, and I can roll a 6 and a 1, and that's all going to get me 7, whereas I only have one chance out of all of them to roll a 2 because I have to hit a 1 and a 1. And for number 4, predict who has a better chance of winning. I put Joel has a better chance because there are 6 possible even numbers that he could roll. So his chances are 6 out of 11 total outcomes. And Haram's probability would be 5 out of 11 for the odd numbers. Alrighty, let's continue. So number 5 says play the game 25 times with a partner. List each possible outcome in the first column. Okay, lost my place because my daughter walked in. So we're listing our outcomes and tallying the results. Part B, you're calculating the experimental probability for each outcome, expressing it as a fraction and a percent. Then we are determining the winner of the game, comparing to see if our winner matches our prediction, and then calculating theoretical probability. Alrighty, and so as you know, I'm going to do this on my own so that I can have my numbers. If your teacher allows, or if you are able, you can also go to an online dice and set it up where you've got, sorry, I'm trying to press settings, there we go, where you've got 2 dice, okay, and then you are now able to roll. So I'm going to go ahead and roll, get some results, and then I will be back. Alrighty, I finished my experiment. Here are my results. All right, so we've got our experimental probability, and we were also supposed to express this as a fraction and a percent. Now, I'm not going to do all of these, but I'm going to show you how you would do this so that you can annotate this on your paper. So, for example, a quick way to find out what the percentage is, I'm going to use, say, number 3 as an example. Number 3, I've got 2 out of 25, so 2 out of 25. I can multiply both sides by 4 to get 100 on the bottom. What I do at the bottom, I switch to the top. That gives me 8 out of 100, which I know is 8%. And when we take that percentage and divide by 100, let me do that in a different color. Let's say orange. When I take it and divide that by 100, you would get your decimal version, which is 0 and 0.8 tenths. So that's just one strategy you can do for all of these to get your percentage and your decimal. All right, number 6. According to your experiment, who would win the game between Joel and Hiram? Explain your reasoning. So let's see. All of our evens and all of our odds, let's put them together. So to calculate Joel's, I'm going to add up all of the times that the coins, or the dice were rolled on an even number. So 0 for 2, 5 for 4, 6 2 times, 8 1 time, 10 1 time, 12 0. So 5, 6, 7, 8, 9 points for Joel. And for, let's use a different color to calculate, let's say dark purple, Haram. So 2, 5, 2, he rolled a 7 6 times, a 9 was rolled 3 times, and 11 was rolled 3 times. So 3, 6, plus 6 is 12, 13, 14, 15, 16 for Haram. So Haram would win this game because the sum of those dice were rolled 16 out of 25 times. Number 7, does the outcome of the game match your prediction of the winner? Number 8, suppose you wanted to calculate the theoretical probability of each sum. Remember, theoretical is what should happen. Explain how you might proceed. So take about 2 minutes max. Go ahead and answer these questions on your own or with a partner. Discuss that. Does the outcome match your prediction? And if you wanted to calculate the theoretical probability, how might you do that? 2 minutes. Pause here. Alrighty, let's compare answers. So, does the outcome match our prediction? Well, my prediction was wrong because I thought that Joel was going to win, being that he had a higher chance. However, Haram won this round because more dice or more odd numbers were rolled on the dice than even. And suppose I wanted to calculate theoretical probability. Well, I could do that by calculating all of the theoretical outcomes. So, for an example, I can only roll a 2 one time. I can only do that one out of, well, let me back up. So to get a 2, I can only roll a 1 and a 1. So I know that it's going to be one out of many outcomes, and I can use those, or I can set up a probability table to calculate the outcome of each. All right, that concludes the work for this activity. We've now just learned how to calculate probability for if we have 2 dice that are rolled instead of just one. Alrighty, great work. I will see you in the next video.